Well, hi again everybody. Welcome to my latest video. This video is actually a redo of an earlier video I did, I think last May sometime, where I went over computer PC power supplies, or PSUs, power supply units. I've learned a bit more in terms of some of the latest available features out there and options. Also, I wanted to clarify a couple of things I may not have originally gone into in the detail I should have. If you see something in this video that you like or enjoy, please do me a favor and subscribe to my channel. It would really help. Okay, down on the table here, I have a couple of sample power supplies that I'll be talking about in some detail when I get into it, but I just wanted to show you these to get started. First of all, there's this one here that's a very inexpensive power supply. I got it on sale. I couldn't avoid it. It was like with shipping and everything else, maybe 20 bucks. So I had to go ahead and purchase it just as a spare. It's not one that I'd want to put into a PC necessarily that's going to be anything particularly business critical, but it'll work probably for most. They always tend to come with the screws. You should always use those screws, as I said in previous videos, because they're the right length to prevent a short when you connect them into the case. It's of a standard size, and I'll describe that in a few minutes what that means. It's a 450 watt from Roswell, and it is a non-modular, and I'll explain that when I get into the presentation a little bit more. But it has all of the available cables that come with this particular power supply connected up. Open this up. It has regular SATA data cables. It has the actual motherboard cables, which most of the time it's the 20+4 on a modern motherboard. Some of the older motherboards may not actually have that. You got a CPU power connector. It allows for an 8-pin CPU power connector on the motherboard. The top left connector, as we've seen in bills. If you have a video card, that would be this one here, the 6+2. So it doesn't necessarily support a very high-powered video card, but it does support, most of the mid-range to lower-end ones. Anyway, that's the basic, standard, non-modular 80+. Now this one doesn't have a rating to it, so it doesn't say bronze or gold or anything like that. So we'll see later, that's the low end of the 80+ rating system. Some companies refer to it as the white rating. Now this one here is a power supply that I've yet to use because I purchased it ahead of time on sale for my supercomputer whenever I get a chance to eventually complete that. Let me open this up. I've shown this before, but that's okay. Now with this one, this has a standard power supply cable in it, just like the other one did, but this one's a lot thicker power supply cable. So if you looked at the actual gauge of the wire, this is probably about a 16 gauge, and this is about a 14 gauge, so it can handle a lot more current through the cables. And you can see the plug is much more beefy as well. That's one of the things you'll notice as you get into the high power, because the one I showed you was a 450. This one is an 850, so it has a lot more available wattage to it and can control a much larger PC. This one also has a rating that's a little bit better than the base end. It is actually a bronze rated, which is still not high end. Some people want to go always to the next levels above that, but I'll explain some of that in a few minutes and you'll see what I mean. Doesn't necessarily help you. These are all the individual cables. I'm not going to parse them all out. This one comes with quite a few. It allows you to connect many different types of options to it. I think it still has, even Molex on it if you wanted to use that, or if you had something that had to use a Molex connector. But as you can see here, when I'll show later, it allows you to connect these cables up to the side of the power supply only as needed. So you only put the ones on here that you would actually have to connect. The other thing here is, and one thing about power supplies, that's why they don't change price that often, unfortunately. There's not a lot of technology changes that occur at any rapid level. The most recent advancement in power supplies is the ability that it can actually control the fan to cycle on, off, and at certain speeds depending upon the load and the heat that the power supply is going through. There is a switch option on this particular one where you can turn that feature on or off right over here. ECO mode. Right now I have it off. I would click this little switch here to turn it on. And that's a standard, power switch. In addition to that, there's some tools you should have available to you if you're going to do more than one PC. They don't cost a lot. I think the most expensive one I have here is a wattage meter. Now there's a lot of different wattage meters out there. This is a base one, but it does an extremely good job. It can tell you what the watts, the incoming voltage, the current level if you're interested in that as opposed to looking at it as wattage, and a few other options to it. This one will do a fantastic job. However, it does not record. If you want something that actually records and something you can later use in graphing mode, you'll have to pay a lot more. This one cost, I think, about $20 when I bought it. Then you got a power supply tester. So if you're not sure about whether the power supply is working or not, you don't have to connect it up to your computer to find out. You can connect this up, and this connector here connects to the 24+4 connector for the motherboard, and these connectors connect to the various 12-volt power supplies that are available for different types of peripherals. Whether they're 8-pin, 4-pin, it breaks down the 8 into 8 and a 4, or a 6-pin. You plug them in, and it basically will give you a little LCD display here that will show you the status, and various lights will also light up to tell you what voltages are present. Handy little thing to have, but it will not tell you if the power supply is intermittent. It will only tell you if the power supply actually has lost one of the voltages, because it doesn't provide any load to the power supply, so it has limited testing capability. The only real way to test load is with advanced equipment, which most people are never going to have unless they do computer repair as a profession. And then finally, this little piece here, and this doesn't cost much. It costs about, I think I spent less than $3 on it. If you buy a high-end power supply, something that's 1,000 watts or more, they'll include one of these with it. This is mainly used if you wanted to have the power supply turn on without being connected to a motherboard. By default, the power supply will not activate unless it's connected to the motherboard and you hit the power switch on the motherboard. Well, there's a way to cheat it. If you put this little wire jumper between two specific pins here, let me see which pins those are if anybody's interested and they happen to have a connector that shows it. Pins 16 and 18. So just this little jumper here. You could also, if you wanted to, you could actually do it right onto the power supply cable. But I don't recommend doing that. You might actually cause yourself to get a shock. This way you can just plug this in and it'll come on. This is needed, by the way, if you're doing custom water cooling, because you generally want, after you've built up your custom loop, you want to be able to test it without the computer on, just in case there's a leak. And that's an important thing to know. And also, if the PC itself is off when you get the leak, let's say it sprays onto the motherboard, it is less likely, I won't say it's impossible, but it's less likely that you'll damage something if the PC is not on when it gets wet. You could then quickly, turn this whole thing off, stop the leak, and dry off the motherboard. I suggest drying it with like a hair dryer on low power from a distance. Okay, let's now go over the details of this presentation that I want to cover for power supply units that you might find helpful. Some of this is going to get a little bit on the technical side, but I think it's quite useful to know, especially if you're going to deal with these power supplies on multiple computers. How much wattage is needed in a power supply unit, depending on what your needs are, obviously. Now, the most common power supplies that you would buy today are within these wattage ranges that I've given you here on the screen. 450 watts tends to be the low end these days, and that's a basic starter PC as I've described in another video. You then move up depending on what you've added. If you want to add in a fairly high-powered video card, if it's a gaming system, I would go up to 550 or possibly even 650, depending on what the card is. So if you have more than that and you want to actually, let's say, add a higher end video card or some other peripherals like a lot of disk drives, you may want to go to a 600 or 650 watt. But then you can move up from there. As I said, there's 750, 850 I just showed you in the sample that I had, this EVGA that's going to go in my supercomputer. Then you can go even higher than that into 1000 or 1200. Those would be really, really beefy systems that have a lot of things on them, mostly a lot of video cards or maybe a server that has multiple CPUs on it. I already showed you the watt meter. That's something you should invest in my opinion. Let's say you're going to upgrade a PC. You should probably have one of these and try it with your PC under load, running some sort of gaming simulator. Find out how much power it's drawing at that point in watts, and then add the piece in just to see what the wattage is. And if it's well below the thresholds that power supply supports, you may want to look at upgrading that as well. I like to go online if I really want to take a look. Now, I think I recommended a different site previously, but since using PC Part Picker, the latest version of it, I found that it's extremely helpful. Let me give you a show here of getting onto that website. So when you come into the PC Part Picker, that's pcpartpicker.com, all you have to do is go into System Builder. And I'll give you an example of running it. For example, let's just, the basic 3-part. Let's say you've got a particular CPU you're interested in. I'm just going to pick one randomly. Let's say the Ryzen 3700K. I'm going to add that. The first thing you'll notice right here, it tells you what the wattage requirements of that PC is. Just by having that CPU in it, the requirements are 105 watts. Now, if I go ahead and add a motherboard, let me pick a decent sized motherboard, MSI MPG X570, for example. We've jumped up to 175 watts. Okay, let me add a video card, EVGA 1360X. Let me add that in. Look what happened here. We have a 325 watt requirement now. That's without adding anything else. The best way to size this is to double this number. This is my recommendation. You'll see why in a couple of minutes. So that comes out to what? 650 watts. It just so happens there's a power supply that fits right into that. Try to round up if it's not too far up. Plus or minus about 5% won't matter. So this would be ideal for a 650 watt power supply. If you went down to PC Part Picker and you picked the power supply, I think it'll actually warn you if you picked something that was too low. So let me pick a 650 watt and just add that in. And we're happy. There's no warnings or anything else with this. If you were to pick one that was too low for that type of equipment, it would give you a little warning here in this green box. Now let's talk about the different types of power supplies. I already showed you 2 types. One like this, the standard PSU non-modular. This is what we call a semi-modular. Some cables coming out of the center grommet. In this case, only 2 cables are coming out. The 2 for the motherboard. The one that goes onto the regular 24+4 connector, and the other one that goes to supply power to the CPU. And then these cables here are for the peripherals. So they would plug into these little connectors here that say SATA 1, SATA 2, peripheral 1, VGA 1. So the VGA, that would be for the video card. There's only one connector here for that. So there's one of these is the cable for it. And then here's a fully modular. There are no cables coming out of a grommet from the power supply itself. All of the cables are attached, including the ones that go to the motherboard. Now, why would you want this one? Well, it depends. If you're going to do custom cables, for example, there are websites that allow you to actually order custom cables. So here's one in particular, Cable Mod. It's just one. There's multiple ones out there. It's just one place you can go to, and then you can go ahead and pick the custom cables. You would define what your power supply is. They're going to supply you with the cables that plug directly in on the fully modular power supply unit. The main thing here is you define what you want in terms of length. So if you want to make it really neat and tidy for the case that you're putting the PC in and make it, let's say, a showpiece, you want those cables to only be as long as they need to be. You got to be careful measuring them. If you measure them too short, you're going to have a problem. You're going to have to put an extension on it, and that's going to mess the whole thing up. It'll work, but it'll mess up the look that you might be aiming towards. In most cases, I say that the average person should be dealing with the semi-modular power supply. If you can afford that, I suggest you buy it. That way you only have to put these little peripheral cables in as needed. There's no way around the ones for the motherboard, so those will be connected. So unless you're doing the custom cable mods, there's no reason to go to a fully modular power supply. My opinion, of course. Then finally, there's what's called an SF, or small form factor power supply. It's much smaller than the standard size. What I originally showed you here on my table and on the slide as the non-modular power supply. The actual dimensions, and I'll show you that in a minute, are much smaller than that standard one. And if you're putting it into a very tight case, similar to the one that I built my server in, although I used a full-size one there, a semi-modular full-size one, then this would actually save you some room and maybe some better airflow through the inside of that small case. Now here's an example of what the size differences are between them. So here's the standard one that's that's in the middle, the one that I showed you for real on the table a few minutes ago. Most power supplies out there that you'll find in a PC are this size. There is a larger version of that, usually for the larger wattages. For example, this 1200 watt one I have over here. They have to be longer to provide beefier components inside of it to provide that power. Sometimes there's dual sections to it to provide for multiple little sub-power supplies that go to different connectors on the side of it. And then you have the small form factor one. And in this case, all three dimensions are shorter than the standard size. It's shorter in terms of the room it uses in the case, and it's shorter in terms of what you'll see from outside the case. Most small form factor cases and most of these power supplies that are above the very cheapest will give you the adapter for that. So there's something to realize in the build that you may need an adapter to this. And you can buy those separately if you really want to as well. They're available online. Now let me talk about efficiency. So what do these 80 plus ratings mean? Well, I'm assuming you have at least one of these ratings. If you have one that has no 80 plus at all, then, you're something sub to this. And you're taking a chance if you use one of those non-rated power supplies. Not necessarily the efficiency itself will be a problem, but you also are risking the fact that the power supply is just made of very poor components. It's one of the reasons it doesn't have the rating. And it's more likely to fail sooner. If the power supply were to die, let's say just one voltage completely dropped out, or worse, it started fluctuating amongst different voltages. The 12 volts suddenly jumped up to 20 or 30 volts. That type of failure could actually damage components in your system, even the CPU itself, the motherboard, the video card, all of it. But this chart, which I put together from various sources, gives you an idea of the efficiency levels that are appropriate to each of the ratings. Now, it's kind of hard to see it on this chart, but what I did was I went ahead and made an actual graph showing each of these. So for example, if you look at the lowest level, what's called just the 80 plus, or as I said earlier, what some vendors call the white level at the bottom here. Well, it goes from 80% efficiency to about 82% efficiency, and then back down to about 80%. Now, the curves are not necessarily nice and rounded like this, depending on the manufacturer of the power supply and how careful they are to the component tolerances. Whereas if you jump up the scale, is the 80 plus bronze. That is by far the most popular one that I've seen these days. Then you're going to go from, let's say, 82% efficiency up to about 85%, and then back down to 82. The titanium, those are the real rare ones, very expensive. They'll go from 90 at a minimum up to about 94% efficient. But I wanted to show something a little more specific about this. Why you don't want to buy something more than you need. It turns out all transformers and a lot of other magnetic related equipment, which means coils, inductors, and other components like that, and a power supply has a lot of that. They work at peak efficiency when they're at 50% of the rated load. And you'll see here, where does the top of the bubble hit in every one of these cases? It hits right at 50%. So that is the ideal load, and that's the preferable place to be running your power supply, or somewhere close to it. Obviously, between 40 and 60 is probably just fine. But the closer to 50 you are, more efficient that power supply will be. Now, why does it matter? I mean, maybe you think, well, the electricity is no big deal. It's not going to change it that much in terms of what I'm paying. And you're probably right. However, where does the loss of efficiency go? It goes, unfortunately, into more heat. The components themselves in the power supply will get hotter. And the hotter they get, as I've said in previous videos, the shorter their life will be. Another thing is, which one do you pick? You might say, I always want to go titanium. To me, it's very important, so I'll buy the titanium. Well, that may not be a good idea, depending on where you are in the efficiency curve. Let's say, though, that you happen to be running a power unit that is not at the 50% mark. So you go ahead and buy the titanium, but you're only running at the 10% level of load normally, because you bought one really way over the wattage that you really need, or way under the wattage that you need. You bought a 450 titanium because you were able to afford that. I don't know if that's available or not, as opposed to buying a 650 bronze. Well, what happens to you here? Well, unfortunately, As you see from here, if you did something like that, running at the 10% or closer to the 90%, and you're running a titanium, well, you're only going to be running as efficient as 2 levels below that, the gold level running at 50%. The gold level will actually meet the actual efficiency of the titanium if you're running that one at 50%, as opposed to running the titanium one at a much lower or a much higher level of load. If you have any questions about that, put them down in the comments section of this video, and I'll be more than glad to answer them and go into more detail if you'd like. Okay, so with that, I've concluded my video on power supply units and some of the little detail that I wanted to throw into this that I hadn't covered before. If you got something out of this, either something that you found useful or just enjoyed listening to, please do me a favor and subscribe to my channel. It does not cost anything to subscribe, really. And you won't get bothered unless you click that you want notifications as well. But please subscribe. My little head will pop up here in a moment. Click on it, follow along, and subscribe. It would really be helpful. Thanks for watching.